My name is Louie Meyer, and I will be speaking on behalf of my co-authors. Our project is a research through design exploration based on an interdisciplinary collaboration between scholars in machine learning and human-computer interaction. The aim is to explore whether computer vision can be used to facilitate new ways of seeing or experiencing a digital art collection. Our work focuses on the digital collection of the National Gallery of Denmark. We've investigated the research question: how can object detection be used to support exploration of an art museum's digital collection? Museums around the world have put a lot of effort into digitizing their collections, both as a way to secure the contents for the future and as a way to increase public access, in particular to the large number of artifacts and archives that are not and sometimes cannot be exhibited physically in the museum. In the case of the National Gallery of Denmark, only 0.7% of the collection is on display. Several digital museum collections have become available through online search engines, and in line with this development, new approaches for designing search interfaces for digital art collections have been on the rise. These approaches are breaking with the paradigm of linear information retrieval and instead focuses on concepts that allow users to exploratively browse through a collection based on parameters such as personal interest. The increasing digitization has also fostered the implementation of several AI techniques, and there's a growing interest in applying computer vision to enrich the metadata of what is depicted on the artworks in these collections. Object detection is a computer vision technique that aims to locate and identify all objects from one or more predetermined classes in an image. Previously, vision algorithms have been limited by what has been termed the cross-depiction problem, namely that they could very well detect objects in photographs, but would struggle to detect the same object in different styles of images, such as drawings or paintings. This is very different from humans. Human vision can recognize motifs across a wide variation of shapes, textures, and materials with ease. Recent progress in computer vision has led to algorithms that are now comparable to human performance on some tasks. These images show Pablo Picasso's series of lithographs titled The Bull. We've chosen this example because it demonstrates a wide range of depiction styles, from very lifelike drawings to increasingly more abstract styles. The image to the left shows the result of a test we ran in 2021. At the time, the fast RCNN algorithm pre-trained on the cocoa labels could only classify 3 drawings as a cow, since the cocoa label set had no separate category for bull. The image to the right shows the result of a test we ran in 2023, using the GLIB algorithm on the same image, correctly classifying even the most abstract drawing as bull. This illustrates the great technological advancement in cross-depiction object detection, now making it feasible to use these algorithms on art collections with a degree of precision that has previously been unmatched. As we set out to annotate the digital collection of the National Gallery of Denmark, we constructed a dataset of artworks that were labeled as paintings. This resulted in a set of 6,750 artworks. Our initial approach for the object detection was to use the GLIB algorithm with the cocoa labels. This gave impressive results. We found that the model could recognize a wide range of objects, even in crowded scenes and with unclear depiction styles. The system did, however, appear to have a bias towards modern object categories, for instance, mislabeling some old books as suitcases or the shield of a warrior figure as a handbag. With the aim to mitigate this, we constructed a custom set of labels with inspiration from IconClass. IconClass is a comprehensive index for classification of motifs depicted in art images. It contains more than 28,000 unique concepts, and our model could only take a maximum of 120 labels. In order to select the set of labels, we iteratively explored concepts from IconClass and observed how often these motifs were depicted in a random subset of the National Gallery's paintings. This process resulted in the selection of 120 labels as illustrated in this table. We additionally sorted the labels across 13 categories that were likewise inspired by IconClass. By feeding the 120 labels to Glib, almost 110,000 objects were detected on approximately 6,500 of the paintings. We defined a subset for the application by retrieving up to 100 object instances per label, selected based on the highest confidence level. Finally, we developed a script that cropped the detected objects from images of the original painting, leaving us with an image collection of the singular objects. These individual object images were used as a key component throughout the design and development of the interactive application. In combination with the results from the object detection, we drew on inspiration from existing literature on designing for exploratory search. Through the design process, we created SMKExplore, a web application that allows users to browse and explore a digital museum collection with detected objects as the primary entry point. In this presentation, we'll give you a brief tour through selected parts of the design. The user is initially led to a screen showing the 13 categories of objects. Here they can choose a theme they find interesting. Once the user chooses what to explore, they're directed to a screen that displays all objects in that particular category. The user can filter the view even further by selecting an object label. This allows them to investigate similarities and differences in how artists have portrayed these objects. Hovering the object will reveal the label and the name of the artist, and if they want to inspect an object further, they can click on it, which will lead them to the painting the object has been detected on, with highlighted metadata of the artwork. This screen mirrors the existing web design of the National Gallery, with the detected objects as an add-on. Hovering the painting will reveal areas of the artwork where the algorithm has detected objects, allowing the user to interactively explore the algorithmic gaze. With inspiration from existing research on exploratory search, we've designed multiple pathways to search through the collection with the aim to support serendipitous discoveries. Users can save objects they find interesting to a list of favorites. This provides an opportunity for the user to curate their own collection of objects, as well as an option to revisit points in the collection they enjoy at any time. The saved objects can also be used to create new images on the interactive canvas. Here they can combine, position, and resize objects. Once they're satisfied with the composition, they can type in a text prompt describing, for instance, the desired image style or theme. The canvas uses the outpainting function of OpenAI's DALL-E 2 API, which generates content in the white space of the canvas based on the visual input and the text prompt. When the image is generated, the user is presented with an overview of the artist and the objects that have been used to generate the image. From here, the user has the possibility of creating new images with different compositions or to continue the search further through their collection. The application SMKExplore was tested on-site at the National Gallery of Denmark on 22 participants. Through thematic analysis, we identified 5 themes, and in this presentation we'll highlight 2. First, the theme, mislabeling and interpretation. Out of the 22 test participants, 12 said that they noticed objects that were not correctly classified. When we asked them if this influenced their experience, none of these 12 participants said that it bothered them. Some participants even offered explanations and sympathy as to why the algorithm would misclassify certain objects, and several participants found it interesting to be confronted with the algorithm's interpretation, which sometimes made them question their own. As an example, we highlight a quote from the interview with participant 14. I guess it made it a bit more exciting, because you didn't know if it was going to be the actual thing. One of them said it was a guitar, but it was an open heart surgery. It looked like a guitar. It was quite interesting. We find it interesting that the test participants generally trust the system's algorithmic labeling, and in the discussion we reflect on several factors that might contribute to this, including the context of the museum, potential attribution of trustworthiness to university researchers, visual noise in the interface and the resolution of the object images, as well as the ambiguity of interpreting art. Finally, we highlight the theme recontextualizing the objects. We included the Canvas feature to support user engagement and exploration of the collection. Through the test, we found that the Canvas encouraged participants to continue their search for objects. When we gave them the task of using the Canvas to make an image, many users were eager to go back and look for more objects they could use in their composition. We found that generating an image through positioning and combining objects on the Canvas made the participants reflect on the artwork's context, time period, style, details, and composition. Without painting, the participants were able to visually experience how styles and details can be merged into something new that goes beyond the original context of the object. This suggests that the outpainting functionality of the Canvas may have a promising potential as a device to facilitate practice-based learning about these dimensions of visual art in a manner that would be much more rapid and less dependent on practical skills than traditional exercises in drawing and painting. In our paper, we offer recommendations that might be relevant to consider for designers working with object detection in digital art collections. Firstly, we recommend that designers pay close attention to the label set used for object detection, as this determines what the algorithm can see when processing the collection. We suggest that collaborations with experts like museum curators or art historians might help identify appropriate labels for the art collections. Secondly, we think it could be interesting for future projects to experiment with deliberately introducing flaws or errors in labeling as a way to provoke reflection and nudge users to question their own interpretation. Lastly, we suggest that designers and art educators might use generative systems to facilitate learning about visual art and composition. For instance, when working with a more narrowly curated set of paintings based on time period or style to provide insight into frequently depicted motifs and typical composition. This presentation highlights selected elements of the project. We invite you to find more details about the project in the full paper. Thank you for your time.